We do instructor-led training through our immersion events, online training through Pluralsight, consulting health checks, hardware performance upgrades, remote DBA where we do system monitoring and troubleshooting, present at conferences all over the world. And you can become a SQL Skills Insider by going to sqlskills.com/insider. A little slide about our immersion events. For 2016, it will be in Chicago, Bellevue, and London. The classes from the accidental DBA to 2 different weeks for performance tuning, a week of IE, HADR, business intelligence. We just added one on SSIS and data analytics. So you can make sure to check those out. About myself, we was doing a vanity slide. I'm a Microsoft Data Platform Indeed. I'm in a user group, but the cool parts are down at the very bottom, where I'm into electronics, aquaponics, which we used to have set up in my office here. I farm chickens, goats, and tilapia. Tilapia is a fish. So with Pluralsight, if you don't subscribe to Pluralsight, send Paul at sqlskills.com an email with the subject line to group and introduction. They'll send you a code good for a 30-day trial on all the SQL Skills content. So that's 120 plus hours of free content to get 30 days. And we included a few of our classes, so 4.5 hours for some 8 lectures and 10 lots, 7 hours on stored procedure performance tuning with Kimberly. Glenn Berry has a 3-part series on his DMV's diagnostic queries. So good stuff that you can get free every single month. So what are we going to talk about today? We're going to talk about knowing your backup types, such as why service level agreements matter, which backup types are correct for you, how to know that your backups are valid. We'll talk about an approach to backing up very large databases. To know how to restore your backups, we'll talk about restore strategies, performing time restores, piecemeal restores, and then ultimately we're going to discuss having a plan. You need a solid restore strategy and have a proven disaster recovery plan. So we'll start off with the backup types. One or a combination of these will be correct for you. So a full backup, partial, differential, file group, file, log, copy only. For most organizations, some combination of the above is what they need to meet their service level agreements. A full is exactly that, backing up the entire database as it was when the full backup completed. That's a restore to that point in time. You have no additional point in time in the restores. You can only go back to your last full backup. Partial, if you have a large file partition database, you can do a partial backup of individual file groups. Differential, all data that has changed since the last backup. File group is just that, you're backing individual file groups. It's very similar to really the same thing as a partial. File, if you were to stop SQL service and copy the MDF file, that's a file level backup. Log is backing up a transaction log. And then if you're doing in differential, hopefully familiar with the only, and you use the with copy only syntax, it's not resetting the differential bit. So lots of backup types. Most people stay in a full recovery model for databases and do a full with a differential, weekly full, daily differential, and then transaction log backups for so many minutes. So I talked about very large databases being able to do a partial file backup. And for very large databases, we're talking hundreds of bytes or more. If you can split that data into multiple file groups using partition views or a sliding link partition, that will allow you to do partial backups, which allow you to do partial restores. So this allows you to restore active partitions or file groups much more quickly. So think about if you had a terabyte database, 200 gig partition that is your active read-write. Your other 800 gigabytes are in multiple read-only file groups. If that's your older data, you would be able to bring the read-write file group online and in that minutes, and then take your time restoring the additional 800 gigabytes after additional space is created, or you're free that data from offsite. And so you can take a very long restore period and shorten it and bring the active data online much faster. And I will demonstrate this for you. So we're covering transactions. So you have to restore. What do you do? When I'm in front of a large group, I'll ask, how many of you have restored a database? And most hands will go up, and then I ask, well, how many have restored a database and then apply transaction logs to it? And I usually only see a few hands that go up. And then I talk about the tail log backup. Who knows what a tail log backup is? Very few people will raise their hand, and I explain that the tail end of the log backup is just another transaction log backup. So the tail end of the log is all transactions that have occurred since the last log backup. Any active system is always going to have the tail log. Modern versions of SQL Server will go to store a database, it will prompt you if there's active transactions, you want to back the tail end of the log. Forget which version now will automatically try to take the tail end of the log backup or overwrite the database. So you have to restore a production database. You're going to need the last good full backup. If you're doing differential backups, then those you have them. And then you need to restore the transaction log backup, and then the tail end of the log backup if you were able to take that. And I'm going to demonstrate a worst case type scenario where I'm going to delete a data file and then show you that I can still back up the transaction log. And then we can restore not as full and log backups and include that tail log and show that we have zero data loss, even with some pretty extensive corruption by delete the database. So any questions so far?
No, nothing so far.
All right, we'll keep going. So you need to have a plan. You need to know how to recover, and that's that's really the gist of this whole session, is showing you how to go about multiple different methods of restoring databases from various backup types. So you need to test that your backups are restorable. And so how's the best way to do this? To have a process in place where you're regularly restoring your backups to a dedicated server. This could be a weekly process or a monthly process, but you need some process put in place where you're actively and regularly restoring backups to validate that you have good backups. If you're in an industry that's regulated, here in the U.S., and we have your financial sector, so you have the FDIC, insurance, securities, anything dealing with medical, basically medical and money and insurance is heavily regulated. So we have auditors, examiners, regulators that regularly come in and audit our books and our processes. So I worked for 18 years in the financial sector, and when we were able to demonstrate our restore methodology, where every week we were restoring every production database, and I was able to show what our DR plan was, they were very excited that we had such a mature process in place, and then they left us alone and beat up other business units. So having a restore validation process in place gives you history of regularly doing restores and shows a level of maturity that not only are you able to sleep better at night, knowing that you have backups that you can count on, it also helps to ease those regulations and examiners and so forth. You need to have a disaster recovery plan. Most organizations, are required, here in the U.S. Again, if you're in the regulated environments, that you have a DR site. Well, you can stand up the DR site, but unless you regularly fail over to test it, how good is it? So you need to have a disaster recovery plan. If your organization does not, then at least have a fairly up-to-date resume. So if something does happen, you just need to go and add the last few projects that you worked on and then get that back out to the headhunters. We talked about testing the disaster recovery plans frequently. That is more than just restoring your databases and making sure that you can connect. What about all your ETL processes, file transfer, jobs that you have that are dependent upon files getting to you? How are those files going to get to you in a DR situation? You produce a lot of files and they get to other people. How are those files going to get to other people during that disaster process? Just putting an app to a database, is that enough? I talk about restoring databases to another server. If you had to restore your production databases to another server, what about the users? Are you backing up master and know how to restore master? Master requires that the version you're restoring to is the same minor revision that production was. So if you're running 10.50.6000 and you want to restore master, you have to restore to 2008 R2 Service Pack 3. And then if you have any hot fixes at 6,233 or whatever a number would be, it has to be that same minor version. So you have to have the same hotfix on that server. That can be very daunting when you're dealing with hundreds of instances of SQL and you're in a DR type situation where you may not have access to the internet. So in that case, you need to get all those user objects created, your users and passwords. So you can script that out. I've included the knowledge base article where Microsoft provides a stored procedure, sp_help_rev login. And with that, you can export out or run that stored procedure output to a file and it has all your users and passwords. Or it's hashed. So then you can just run that script on your secondary server to create all your user objects and permissions and passwords and save yourself the headache of having to restore the master database. Also, having this restore validation process in place will enable you to also know how long restores take. So how long will it take you to restore that terabyte database? If you regularly restore it, you should have that data in MSDB. You can go and generate those reports and see how long those take. It's also a good thing if you have databases that you have certain service level agreements that you can restore that instance of SQL within 4 hours. Well, if your restores are taking 6 hours, you know that worst case, if you had to restore everything from backup, you're not going to be able to meet that SLA. So as databases grow in size, you can have some checks and balances to see that once you start exceeding those service level agreements, you either need to negotiate wider windows of restore opportunity, or you need to implement some other version of some HA solutions, such as database mirroring, log shipping with a load delay, availability groups, things like that. So we're data geeks. We work with Microsoft SQL Server. So this gives you some data that you can analyze and report back on. And facts are facts. You can't speed up the restores unless you have much better, faster hardware. So now we're going to dive into a whole lot of demos. And when we get done with the demos, we'll come back and we'll repeat the whole summary slide. And then we'll say thank you, and we'll be up for questions unless we have questions throughout. So we'll switch over to VMware. Can everyone see Management Studio? And I believe we have Zoom it, so we can zoom into certain things.
Yeah, we have it on a really big screen, so you don't need to zoom or anything. It's all pretty visible.
Thank you. All right, so we'll go with that. So what I always like to do is to restore from a backup so that I know I'm in a known state, because periodically I'll be demonstrating some piece of restores or some methodology to someone, and I'll bring up these virtual machines and then I'll tear up my demo. So I always like to go back to a known state. Pretty simple. We just restored a backup from disk. It's a full backup. I'm choosing with no recovery and replace. Pretty standard syntax. And then I'll restore the database with recovery. Now, I'm usually in a habit when I restore a database to always do with no recovery, just in case I need to apply any differentials or logs. So it's just habit I've gotten into throughout my career. If I knew for a fact I didn't have to, wasn't going to be applying logs and things, then just restore the database with replace. The default behavior is with recovery. And then I'm going to clear my backup history. This is just a habit that I get into for this demo so that other scripts will work. Now what I'm doing here, if you're not familiar with the stored procedure sp_delete_ backup history, this will delete all backup and restore history for this instance. So what I'm doing is declaring a date, and then I'm setting it to tomorrow. And then I'm pass tomorrow's date to the stored procedure, so it deletes all entries older than tomorrow, which is everything. I'm basically clearing my backup media set, backup history, those tables within MSDB. In reality, in production, this would say something like either 30, 60, 90, something like that. So that only keep 30 days worth of backup history in MSDB. The reason that is a good idea to only keep certain retention is when you start bloating MSDB with all this old history, it can slow down your backup job. So we'll go ahead and dive straight into what I want to show you with backups and restores. So right now our max sales order ID is 75123. We're going to do a full backup, then we're going to do a log backup, and then we're going to start inserting records. So we'll insert 75150. We'll do log backups throughout the process. So we'll just kind of walk you through the script. So we do a log backup. After we inserted a record, we'll insert another record, 75200. We'll do another log backup. So that's a third log backup. We'll insert another record, and then another log backup. So in your production environment, if you're doing transaction log backups every 15 minutes, and then we just went through and inserted several records and did log backup. So we simulated 45 minutes worth of production in just a few seconds. So if something were to happen, what would our restore process, our restore script look like? Do we restore the full backup and then we just need this last log to bring the database back to that current state, or do we need all the transaction logs? Well, we'll need all of the logs, but if we take a look, we see that we inserted the 3 records. So if you were to be called at 2 o'clock in the morning stating the system is down and you have a full backup from the previous day, because say your backups don't run until 4 o'clock in the morning, and you have log backups every 15 minutes, then you have a full from the previous day and 100 or more transaction logs that you have to restore. Are you going to type that out through T-SQL, or are you going to use the Management Studio and try to select all the files? What if I told you that there's scripts available that you can run that will generate your restore script? So we'll run this. We see that we have our restore database. So this is our full backup, and then the 4 transaction log backups that we made, and then the final script restore database backup sample with recovery. So if I were just to take this and run it, then we can restore up to this point in time with the last log backup. Now, if you were to incorporate this into your backup routine, so after every log backup or a full backup is made, it generates this file and sticks it out in a folder where you restore your backup your database to. And now you don't have to think about it. You're writing out your restore script every single time you make a backup. And that's what I did for one of the largest banks in the United States when I worked for them. Is our backup routine did this. So we then had a PowerShell script that could loop through those folders and bring a brand new database server that we've never seen before, and bring all of our user databases online, restore MSDB, and it also restored model. Master was sitting out on the server if we needed it, but we were also scripting out all of our users and permissions to a file. So all you had to do was go open that script and run it, and it would apply all the users, the Active Directory groups, and then things just worked. So this was very, very nice to have. But what if we were doing full backups and differentials? So we'll clear and restore back from backup. We're going to clear our backup history again. Then we'll walk through the same process, except here we're going to insert a transaction. We'll do a log backup. We'll insert another transaction. And this time we're going to do a differential. Now, if you're not familiar with differential backups, it's still standard backup syntax, backup database, your database name to disk or URL with differential. So nothing complex, you just specify with differential. And it's awesome script. So then we do a differential, we insert a third record, we do a log backup, and then finally a fourth record and another log. So what is our backup sequence going to look like? What do we restore first? So that's a full backup. And then what next? Do we need all the logs? Do we do the differential, then the last log? If you're not doing this all the time, it may be confusing. So again, similar script that we can run. Or this one's looking for the most recent full, then the most recent differential, and then every log backup since the differential backup. So this gives us our full diff, and then the last two logs, and then we restore with recovery. So again, the script's nice, but it also has that safety net of helping you with the order of operations for bringing the database online. Now, if something were to be wrong with a differential, or say somebody gave a midweek full backup and blew up our restore chain over differential, say this differential, they made a full, we don't have that full, we still have our logs. So you can still go back to this full backup and log 1, 2, and then 3 and 4 and get the same result. So I like to think of a differential backup as a cumulative log backup. So it's all transactions that have occurred since the last full. And if through any of these demos you guys have questions, you just have Cody come up and interrupt and ask questions. We talked about in the slide having very large databases and being able to do a piecemeal restore. So we're going to switch over to another database. This one's called backup file sample. So much the same way, I'm going to restore to a known point. And we'll take a look at backup file group sample. Take a look at the properties of it, and we'll see that under files, we have a single file for data, a single log file. In our file groups, we just have a primary file group. So much like any normal user database. What I want to show you here is that we have roughly 121,000, we'll zoom into that. So 121,000 records, and that our date ranges from 2009 through 2012. So I really should go in and update my data set so it's current data. In case I blow something up, I'm going to go ahead and do a full backup. We're going to partition this database. So we need to create additional file groups. And then we're going to assign files to that file group. So since this isn't a partitioning session, you will see how simple it is though to partition a database. So if we take a look now at our database, you see that we have additional file groups, 2009, 10, and 11, that have files associated to it, each one starting at 1 megabyte and auto-growing by 1 meg. So this is modeled after model, so this is not behavior that I would want to see in production. However, it suits this demo pretty well. And you'll see why. So now we're going to call a partition function. We're going to put all 2009 data in the 2009 file group and so forth. Just a small bit of code. We now see that our 2009 file group grew by 6 meg, 2010, 2, and 2011 by 3. So we now move data from that primary file group into the secondaries based on date constraints. Let's go ahead and get a backup after the partition. Now we're going to specify in this backup individual file groups. So I'm going to back up each file group independently. However, I could just run this backup database file group sample and specify a file group primary. Once I've had 2009, 10, and 11 backed up, and I know that those backups can be restored good, and I know that I've run checkdb after those file groups have been backed up and I have no consistency issues, then I can specify in this weekly or nightly full backup only the primary file group. Let's go ahead and execute. I'm going to show you that all of my data is still here. We still have the same 121,000 records. And let's restore just the primary file group. Now, here's where things get interesting. If you've never done this, you'll see syntax that's new. So we're going to restore database, our file group sample, specifying file group primary from disk. So the only thing unique right now is we're specifying the file group equals primary. What we're going to do with partial, and of course then recovery and replace. But with partial, the only time that you can use this is when you're restoring the primary file group. We're telling SQL Server to do a partial restore, so only restore the primary file group. And I have to change to master first. Okay, so that was successful. We've restored just the primary file group. Let's take a look at this database files and see what's going on. So you see that the primary file group is online. However, the secondary file groups are in a recovery pending state. That's kind of cool. So what happens if we try to select data within that primary file group, so the active one? We can view 50,000 records. No errors, 50,232 or 34 rows. What if we try to query data that's outside of the primary file group boundary? We get an error. One of the partitions of the index for the table cells gives us the partition ID resides on a file group 2009 that cannot be accessed because it's offline, restoring, or defunct. So this may limit the query results. Well, it did. We got no results. So now we'll restore the 2009 file group. You notice we don't have to specify partial or anything like that. It's just restore database name, and the file group. So we'll run that query again and see the state. Let's see, 2009 is online. So here, if we specify with a modified date between, so we're only looking at 2009 data, we see that we have 43,948 rows. That's pretty cool. So what happens if we go outside of 2009 again? So we're doing everything greater than 2009. We get an error for the partition 2010. Again, it may limit your results. So we go back to results, and we do have those same 43,000, or we have 43,000 records that came back. This could be problematic for your users, though, executing searches within the application. When when it gets that error, is it going to throw an error in the application or only show them the results there? When I've done this, I did this for that production, or for a production system for that bank. It was a system that users were able to access checks and statements and things like that. They were already constrained within the consumer application with a 90-day window. So we always kept the active year in the primary file group, and so it wouldn't roll over until after first quarter. So we wouldn't partition until first quarter of current year. So in this case, after March, as soon as we started in April, we could partition January, February, March into another file group. Or excuse me, once we got through March into April, then we could do the end of 2015. So fourth quarter 2015 could then be partitioned so that we always had that rolling 90-day or quarter in the primary file group. So the consumer application would always work because they were already constrained. However, the back office, the people that worked at the bank that were working subpoenas and things like that, we would have to instruct them within their application where they could put the begin date and end date, that they could only view data that we had brought online. So in this case, they could do 2009, the whole year, and then 2012 and above. So through Management Studio, if we search just 2009 and just 2012, you can see we have 94,194 records and no errors. So we'll go ahead and bring the rest of the file groups online. We'll confirm that that did work. So everything's back online. We'll search again and we have the 121,173 rows back into the database. So was that complicated? No, not at all. We have to understand a few other things with bringing database online, file groups online in different orders and things. It's an enterprise feature for doing those restores when the database is online. Standard edition, you can still accomplish this. However, doing those restores is an offline operation. Okay, that's fine. If I'm in production, even if it's a 24/7 business, and we have such a catastrophic failure to production that we're having to restore a multi-terabyte database, if I'm able to restore customer functionality within minutes to very low hours, and then have to take a hit during low peak time, so if there's only 10 users in the system at 2 a.m. and we need to take the system down for an hour to do this maintenance to bring on the other file groups, that's better than being down 24 hours straight. So we would take that hit. So this is pretty cool if you're able to partition those very large databases to not have to back up all the data every single night or weekly doing full backups. Once you've backed up those read-only file groups and you know that you can restore them, you can stop having to back that data up because you've already got it. It's not changing. So kind of the cool thing to know, to practice and play with. All these scripts will be made available to you, so you can take the AdventureWorks database and create this stuff. Also include the backup sample and backup file group. I created those in, I want to say 2008, so version 10, so that you can still restore those to 2008 R2, 2012, 14. I haven't done it with 16 release 1 yet, but there's should work just fine. And then you can, of course, change it from AdventureWorks to something else. So we talked about the tail log backup. This should look familiar here. This is from our earlier demo where we ran our restore script that creates our restore statement. So we're now going to use that. So we're using the files that we created in the first demo. So we bring our database back to a known state. We'll take a look at the top one sales order ID, and we'll see that we have 75250. So we're going to insert another record. We're going to insert 5 nines. Hopefully you know the significance of that. We want 99.999% uptime. So just to show that we have two records, so we have 75250 and 59s. We have not done any additional backups. So we're going to switch to master. I'm going to set my database offline. We'll come here and go to my SQL data folder. We're working in the backup sample database. We'll take our backup sample MDF file. And I'm going to delete it. So we have no database file. If we take a look at the state of the database, we see that it is offline. So if we try to set it online, of course we're going to get a nasty error stating that it can't find the physical file. But let's take a look at the database properties. Now it's in a recovery pending state. So that's pretty important. So what happens if we try to do a regular log backup? It's going to fail. It says backup sample cannot be opened due to inaccessible files or insufficient memory, disk space, see the SQL Server error log. The operation is terminated. If we do with no truncate, so do not truncate the transaction log. Do not issue a checkpoint. Just back up what you can. We now process 3 pages. We just backed up the log for a database that has no data file. That's kind of impressive, isn't it? So now we'll take the same script as above. We're going to include the tail log, transaction log that we just made. And we see that we were able to recover the 59's transaction. Now, that's pretty cool. If you're like me and in production, as a production DBA, your databases continue to grow. And on occasion, you have to ask for more drive space. Hopefully, you'll never be like me, where you ran into a situation where you asked for additional drive space, and the SAN admin said, sure, no problem. I just need to format a new one to provide you new storage. And then all of a sudden, I start getting phone calls. Nobody can connect to the database server. I get a call from the SAN admin that says, oops, I formatted the wrong one. So the data drive is gone. I have all the LDF files still, but I have no instance. So with the LDF files, I had heard of a thing called a hack attach, where you can attach a transaction log from one database to another database and still back up the tail end of the log. So let me show you how to do that. We'll come over to another instance. We'll expand databases, we'll refresh. So we see that we have no databases on this instance, just our system databases. So we're going to create a database called backup sample. We're going to alter the database and set it offline. Now, because I have access to my other instance, I'm able to grab my backups and able to grab the log file. So we're going to grab the log file, and I'm going to overwrite the existing log. I could have just as easily deleted and then copied over. And we're going to delete the data file. We'll take a look, and we'll see that we have a backup sample database that's offline. Try to bring it back online. Same nasty error we saw before. We refresh. Now we're in a recovery pending state. So we're going to backup log with no truncate. We just successfully backed up a transaction log of a database that did not exist on the server. So we attached a log file to a database that we just created. It was a shell of a database, had no data in it. It was in the same physical location, same path as the production database that just died. And then we replaced, so we changed out the log file. So the empty log of a generic just created database with the transaction log from production that had transactions in it. And we backed up the log. So because we're smart DBAs and we're backing up our databases to a server other than the production server, So it's going to a NetApp or data domain or some network share. We have access to it. So we're going to restore our four logs and the tail log that we just made. And we take a look and we see that we were able to restore that transaction. So folks in the room, I like to refer to this as an extra week of holiday, a promotion, a bonus, ransom, whatever you want to call it. You're able to salvage and save your company reputational loss from having to tell customers that you lost their data or potentially lost their data. It's easier in situations like this if you have access to the transaction log file that you can get those transactions. Yes, it's going to take you a little bit of extra time, so it's going to be a longer recovery time objective, but your recovery point is now 0 data loss. If the transaction was committed, you just got it. So I would much rather apologize for being down an extra 5 or 10 minutes than to have to email my entire customer base and say, hi, sorry, if you had any business with us from X time to X time, we don't know about it. We lost it. We lost your order. Please come back, confirm, check their system, see if your order exists. If it doesn't, sorry, can you enter it again? You're probably not going to retain those customers. At least this way, you can get the data. So let's switch back over to our first virtual machine. With SQL Server 2014 introduced encryption. So now natively within SQL Server, you can back up with encryption. You don't have to use third-party tools. Redgate SQL Backup Pro for versions prior to 2014 had that capability, which is fantastic. One of the big problems with SQL Server backups is if you're not using TDE encryption or some other third-party encryption, anyone that can have access to those backup files can restore them to a copy of developer edition and have access to all your data. So, okay, I trust my systems engineers, but who all are domain admins that have access to the network share, who manages the data domain or the NetApps or those systems, if they have access to the database files. So if you're backing up payroll, you're backing up things like that. That's some pretty sensitive data. So if you encrypt those backups, they have to have the keys in order to restore the data. That's fantastic, but so do you. You have to have those keys to restore to another instance. So now key management becomes problematic, where you need to store those keys, be able to restore, recover those keys, and so forth. So it adds some complexity. So you're locking out the bad guys, but you're also locking out yourself if you don't have those passwords to the keys. So we'll kind of step through this. So in order to use the backup encryption, we're going to first make sure that my instance is clean by dropping any master keys. So I've already done that. So we just need to create a master key. So we're going to create master key encryption by password. We're going to create a key, and we're going to give it a password, and I'm going to use SQL Skills app. Very secure. That meets the security requirements. Uppercase, special character, over 8 characters, yay. So now we need to create a certificate. So we're going to call it SQL Skills Encrypt, and you can give it a subject if you'd like. And before we can start using the certificate and this key, we have to back those up. So we have to back up our master key to a file and then encrypt it with a password. And then we're going to have to back up our certificate to a file with the private key and also give it a complex password. We'll go ahead and do those. And these are the keys I'm saying you have to store and remember, and you'll need your password in order to restore those keys. And you'll see that in just a moment as well. So now we're going to back up our database, and we're going to back up with encryption. So we're going to specify encryption in our algorithm. We're going to use the AES 256, and with our certificate, SQL Skills Encrypt. We're going to choose with compression, because there's always been this kind of myth that if you use encryption, then you lose the ability to compress. So we're going to debunk that right now. And then we're going to back up the database with no encryption, no compression, so that we can show the difference in those packet sizes. we'll take a look. We're backing up to SQL Backup. We'll expand this out. We'll see that our encrypt compressed backup is 4.52 megabytes, and our regular backup is 15 megabytes. So let's expand this to gigabyte size. So went from 15 gigabytes to 4 gigabytes, 4.5. That's a pretty good compression ratio. What do you say? 60+% or so. And then you also see that we backed up our master key and our
Tim, something has just broken.
unable to see the screen.
There we go. It's back.
Okay. All right, so we need to restore an encrypted database. If you're on the same instance where you created the master key and the encryption key and all of that, there's nothing special that you have to do. It's just restore database, your database name from your backup location with replace. So we'll do that, and we'll see we backed up successfully. However, if we drop our encryption key, and then we attempt to restore, it says cannot find server certificate with thumbprint. And this thumbprint is the problem here. So let's create the certificate with the exact same name and subject that we did before, and attempt the restore again. We get the same error, so the thumbprint. So even though we created the exact same certificate, every time you create it, it gets a new unique thumbprint. So it's always unique, and it has to have that specific one. So we're going to drop the certificate we just created, and then now we're going to create certificate from file, and we have to decrypt it with the password that we use. So this is where those passwords come into play. Even though we have access to the encryption key, if you don't have the password that you encrypted the key with, you have nothing. You just have a file. So we restore our certificate, and now we can restore that encrypted backup. So what about if you're on another instance of SQL Server? So we'll go back to the instance that we did the hack attach on. We'll make sure that we have no keys here. So we're going to create a new master key. It's called New SQL Skills, so not the same one as production. We're going to create the certificate from file. We're going to decrypt with the encryption password. And now we're going to restore that encrypted backup. So pretty simple. As long as you have your key, and you have the password that you encrypted it with, and you've created a master key, it doesn't have to be the same master key, but your certificate that you encrypted the backup with is what's crucial here. And you can have multiple certificates on the server. You have a different key per application, per database, however complex you want to make it, you can do that. So kind of neat. I mean, encryption, again, it's kind of like the file group stuff. It's not overly complicated, but it is different than just regular full differential transaction log backups. As long as you know kind of the methodologies and you've gone through, played with it, and you've experimented with the different methods of restoring, it's not that complex. So with SQL Server 2012, Service Pack 1, cumulative update 6, maybe 6 or 7, something like that, Microsoft introduced URL-based backups. And this reminds me of the Ford Motor Company back when, in the early days of the Model T, Ford stated that you could have the vehicle in any color that you would like, so long as it was black. So here, URL-based backup. You can back up to your URL, so long as it's Azure. I've gone through on, I think it's under security and credentials. You create a credential, and so I have Azure backup. I also have one for intersection when I'm doing that conference. So we create the credential, pretty straightforward, new credential. You give it a credential name, your identity, and then your password. And those are things that you get from your Azure portal account. And so when you go in and you create the blob, you'll get an identity, which is your blob container or name, and then it gives you keys that you put in for the password. So we have our credential Azure Backup. So the syntax, backup database to, previously you've been seeing file, so now URL, and this is your Azure blob storage account, and then you give it a name. So increment this down because you can't overwrite the blobs that are there. And we'll back up database to the URL, to my Azure account with credential Azure Backup. We can still use compression, and I'm going to do stats equal 1 so that we can see it incrementing up. And depending on your internet connection, it can be pretty quick or it can be fairly slow. So you want to make sure that whatever region that you're in, you're backing up to a region that's fairly close to you. And so backed up and then push that up. Usually it completes in around 26 seconds. Okay, it's 23 seconds. So we just backed up this database local on a virtual machine on my laptop in Columbus, Georgia, to the southeast Azure data center, wherever it's located. So kind of cool. So what's a backup process from the URL look like? Store database from URL, specify your credential, and with replace. So it's really no different. If this was a local on a network, it would be a URL for a file share, or it'd be a drop letter. So 23 seconds to back up. We'll see how long it takes to restore. I'm estimating 30 seconds or less. Usually it's just slightly longer than it takes to push the data out. And in this case, with your Azure storage, you could push these things up into Azure, and you have your storage space there. You really only get charged for when you pull that data out. So now my Azure account's taking a hit as we're pulling this database back out of Azure. And it took 25 seconds. So not bad. And that is, let's see, we have the last one. So I talked about point in time. Now, point in time, most people refer to that as just restoring a full and restoring a transaction log. Hopefully you all know that you can stop at a point in time within a transaction log. So if I'm backing up every 15 minutes and I know 7 minutes in, so I backed up at 12 noon, then 12:15 in the afternoon. At 12:07, somebody ran an update without a where clause. Something bad happened. Do we want to lose that 7 minutes or 6 minutes before that 7th minute occurred? So I want to stop just before the bad stuff happened. Yes, you can do that. Due to me needing transactions occurring to be able to show you point in time, I've already pre-staged this demo, but I'm including the syntax, the steps that I went through so that you can duplicate this. But I'm going to go ahead and restore to a known state. And we're still using the backup sample database, but it's a different path. So point in time. I've created a table called point in time. Just give it an identity in the date time column. And then we're inserting values into it. So just the date. And I waited 30 seconds and moved through it 10 times. And then I backed up the log. So down here we have, we'll restore the backup sample with the full transaction log. So that's what you would normally be used to. When we take a look at the point in time table, and we see that we have the 10 transactions. So what if it's 50 or 9:56? I guess it was 2 a.m. or 2:09 a.m. 56 milliseconds. Is when the problem occurred. So between the minute of 2:09, we want to restore to 209 and 26 milliseconds and nanoseconds. You specify with stop at and the time that you want to stop within the transaction log. So our fifth increment here. So specify with stop at, and it tells us that we've restored 7 pages. We take a look at the point in time. We'll see that we stopped. So within this transaction log, we stopped midway through it. So you can get as granular as you need to. If you have the time to go in, we could restore on up. So if we said at 210, and set zeros in here. I have that next transaction. So if we were to do this and say, okay, well, it happened at 210, and we ran it, and then we're looking here, and we didn't need this transaction. This was the bad transaction. And we know that we can then back up to a previous minute, because you may not always have that date time to know exactly when it occurred. So you can step through the transaction log and see when it occurred, and then roll back. So you can take some time walking through it, but if that's the difference in hundreds of hours worth of work or notifying customers or things like that, it's definitely an option. So that is all the demos. Like I said, within the PowerPoint, a lot of demos. We come back, we talk about the backup types, how that pertains to your service level agreements. We talked about having a restore strategy, knowing how long the restores take. We just demonstrated the point-in-time restore. We did piecemeal restores. We talked about having a solid backup strategy that meets your requirements, disaster recovery plans. And what's really important is the first time that you perform a restore, like we just walked through, should not be in production. You should be familiar with these things, to where if you get that phone call and you're having to restore in the middle of the night, you're not freaking out. You're seasoned. You know what to do. You've done it many times, and you don't have to sweat it. And the absolute best way is having those restore scripts already out there for you, so you can just go and pull those up. And all that data comes straight out of MSDB. I want to thank you all for attending. Hoping you all have nice weather. I have another hour and a half or so before the sun comes up. Cody, questions, comments?
Okay, thanks. I'll just ask around. Anything? Someone asked if the only benefit of doing differentials is that you don't have to apply every log along the way, or is there other benefits as well?
Okay. Not having to apply the logs is very helpful, but me not having to back up a 100 database every single night, I'm only backing up the change data. So if I do a full on Sunday and differential Monday through Saturday, then I just eliminated potentially 600 gigabytes of backup space. I only had a gigabyte of data change. And then if Tuesday was another gigabyte, then that differential would be 2 gigabytes, and so forth. So by Friday, it's a 5 gigabyte backup instead of 100 gig again. It really reduces your backup size, and then we'll reduce the complexity of the restore by eliminating a whole lot of transactional backups.
And that's simple mode as well. So it's possible if you had it in full mode and you're not, if you had it in simple mode and you're not taking log backups, you can just do differentials to stop having to do. Yeah. Yeah. Yep, so with a full backup, where you're taking the logs anyway, the differentials that you're taking are basically just taking extra space. Is there any speed advantage from restoring a diff over a lot of logs?
Not necessarily, but if you're only doing a full and then logs throughout the week, then your vulnerability there is if something happened within your log chain, if one log got lost or corrupt, then that's it. At least then you had a differential after that corrupt log, then you could still get your database back. But most shops I know, if they're doing fulls, they're doing daily fulls. They won't do a weekly full and only log backups. They would have those differentials each night, midweek, throughout the week.
Okay, great. While you were talking about tail of the log backups, so you demonstrated one which was using no truncate. And if you do a log backup with no recovery, that takes the database offline. That's a tail of the log backup. Are those the only two scenarios where you get a tail of the log backup, or are there others?
So with the no truncate was with the missing data files.
Yeah.
If you had a corrupt database, you could still get the log. And with no recovery, it's just a final log, because you just set the database offline. You set it offline or read only. I think it's offline at that point. But yeah, those are the only two that I've used that I'm aware of. Maybe others, but I'm familiar with them.
For the partial file group restores, where you have multiple file groups and you're just restoring some of them and trying to keep the database online, does it matter whether those file groups are read-only or read-write? Or in your scenario, was it that you have to restore the read-write ones first before you can restore the read-only ones? What's the split there?
I believe you have to restore the read-write file groups, because then you have to apply any transaction logs to that, because the transaction logs are for the database, not just individual file groups. I believe the initial restore has to be all read-write. In my case, there were the additional file groups were read-only. So that's a good question. I'll need to go and test that out and get back to you.
So also in that scenario where you have those read-only file groups, would they be read-only in the beginning and you can somehow partition switch the data into it? Or are those file groups where you've already put data in and then just one time you set it to read-only and then that's it for that file forever?
Yeah, so you can change the read-write status, and even if it's read-only, you can still add data into it. It doesn't lock it out. But you'd have to bring it back into read-write. You could add data, make it read-only again, and then just back it up and so forth.
And what's the kind of best practice for that? Because I imagine you wouldn't want to change it to read-write again and back to read-only, because then you might think that you have a backup of this read-only file that's not going to change, but then it does change, and then your backup strategy is broken.
Yeah, so the only time in my career that I had to change a read-only back to read was if we had a bank merger. So one institution became another, we needed to go into those individual file group updates. So say if it was bank 999 became bank 777, it would be an update where set inst equals 777 where inst equals 9. Once we make those changes, then we'd switch back to read-only and have to do our backups all over again. It's a very rare occurrence.
In the scenario where you were restoring multiple log files and you were restoring it up to a certain timestamp, if you didn't know what timestamp you wanted to get to, is there any way to view the data while the database is still in no recovery? Can you? I've tried creating snapshots. You can't create snapshots in that case, but can you do it? can you do like a restore with standby or something like that? So you can temporarily look at the data and then possibly restore more logs, or is it just not possible?
Yeah, you can do the with standby. But still, once you would apply the transaction that was the bad one, that there's not an undo. So there are log readers, programs that allow you to kind of walk through the transaction log to see what's happened, and potentially then choose your time more wisely. I haven't done that. I know it exists.
Okay. I just had one more. These are all my questions that I just wrote along the way. This was a scenario I had earlier today. If you have a database in full recovery mode, and you have a log file that's full, and it's on a disk that's full, so the log can't have anything more written into it, you can't take a full backup, because the full backup complains that it can't write to the log. Is there some kind of checkpointing process that happens with full backups that it needs to add something to the log when it's done or when it starts, something like that?
I mean, there is the checkpoint, and that's where when we had to do the transaction log backup for the tail log, we had to choose with no truncated, so it would not write to the data file or log file. Like in your case, where the transaction log drive was full, and you couldn't back up the database because there was no space. I've heard of situations like that where you could then go and add a second transaction log file, although that's really bad practice. You really never need more than one log. The caveat that I've always read is unless you're in Cody's situation where the log drive is full and you can't do anything, then you can add a second transaction log file, and then you should be able to do the backup, because then it would issue or just write the checkpoint to that second file. And let you get past that point and then be able to truncate the log or shrink the log. But yeah, in those situations, I mean, they're pretty smooth. It's a rock and hard place.
Yeah. When you're doing a full or a diff backup, are log backups still able to run in the background? Or do they block?
I want to say yes. I believe with SQL Server 2000, log backups did not occur when a full was being ran. With 2005 and above, or maybe off when, not in 2008, that log backups would still occur during the full process. Because that was a big vulnerability with the older version, was if it took 6 hours to do the full backup, we're in bad shape. We now have a vulnerability of 6 hours of potential data loss if the logs aren't still backing up, because it's a 24/7 system.
Yeah, that's what I was just thinking of. And users often ask, if you have a long-running backup like that's going to take 4 hours, does the full backup contain what was there in the database at the beginning of the backup, or what's in the database at the end of the backup?
At the end, when it completes.
Okay, great. Well, that's everything. Thanks a lot for coming to present for us, and I'm very grateful, and it's a great presentation, so thanks a lot. And thanks to On-Call DBA for catering as well. And thanks, Tim.
Well, thank you.